Hello my dear students, how are you? Everyone fine? Okay. The topic of today is concept of radius of curvature. Means what is the process to find the value of the radius of curvature? Let us consider you have to give it a numerical, you have to solve this. Find the radius of curvature of a body of mass 0.2 kilogram projected at 30 degree, means this is the case of the projectile. Mass of the body is so much is given and the angle of projection is a 30 degree given with the horizontal, and velocity of the projection is also given 12 meter per second, and you have to find the value of the radius of curvature. Radius of curvature at height 0.4 meter, at height 0.4 meter from ground. Okay, from the ground. Okay, what will be the process? What is the process? You know the radius of curvature is how, what is the value of the radius of curvature? Anywhere the radius of curvature, this is the fixed formula in the case of the chapter projectile. The radius of curvature always r equal to, okay, r equal to square of velocity upon normal acceleration. Normal acceleration. Normal acceleration means what will be the normal acceleration? The angle of acceleration and the velocity, means the angle between the velocity and the acceleration should be 90 degree. Should be 90 degree. Sure, that should be 90 degree. For example, suppose you have to find the value of the radius of curvature. Let you have to find the value of the radius of curvature at the maximum height. Then what will be happen? Suppose this is the velocity of the projection is u, angle of position is theta, this is the horizontal component you know well, this is the u cos theta, this is the u cos theta, and this is the vertical component of the velocity, this is the u y equal to u sin theta. Suppose this is the u sin theta, this is the u cos theta. Since you know that horizontal component is always constant, u sin theta continuously going to decrease. How it is, why it is so? Because the acceleration due to gravity acting downward. This is a constant. Why? Because this angle is 90 degree. What is the concept behind this? Since the velocity, angle between velocity and this force and our acceleration is 90 degree, and therefore this will be constant forever. This will be constant. This will be no change. And reason behind this, since there is no acceleration in the horizontal direction, first concept, and the second concept is due to this 90 degree, the work done by this force on this component will be always zero, and therefore there will be no change in the velocity. And also you can say that there is no any acceleration is given along the x-axis, and therefore this component will be always constant. Putting the value, since u equal to given in this question 30 degree, and u, the value of this u, velocity of projection, is 12 meter per second is given. Okay, and therefore what will be this value? Horizontal component. Therefore 12 into cos 30. How much will be that? 12 into cos 30 root 3 upon 2. You will get 6 root 3 meter per second. You will get 6 root 3 meter per second. This is the horizontal component. That will be at every point. At here, what is the value? That will be the 6 root 3 meter per second. Also at this point, what will be the value? So you can say 6 root 3 meter per second. Means the velocity is the v here, and this is the vx equal to v cos alpha. Suppose this angle is alpha, and this value will be how much? Vy equal to minus v sin alpha, because the direction has been changed. Now the projectile is coming downward, and therefore the vertical component taken, here taken positive, therefore the due to opposite direction, here it has to take negative value, means the v sin alpha, and this angle is, suppose this is the alpha. But since you know that the horizontal component is always constant, and therefore this is always, that will be the always constant. And when this projectile will strike on the ground, when this projectile strike on the ground, during the striking time also, this will be constant 6 root 3 meter per second. Throughout the journey, the horizontal component will always constant. There is no change. But vertical, what is being of the vertical component? So since G is always acting, G is here just at the time of projection, this is at the 180 degree, means the G acceleration due to gravity and U sin theta vertical component at the velocity of the projection, both are in the opposite direction, and therefore U sin theta continuously going to decrease. And suppose, since in your question mentioned in the question that you have to find the value at some height, suppose this height is equal to how much? 0.4 meter. This height is given 0.4 meter, and very easily now you can find that what will be value of here. Okay, because you know the formula. The radius of curvature is always square of the velocity at that point at which you have to find the value of the radius of a curvature. Therefore, at that point you have to find the velocity, square of that velocity and the normal acceleration. By the ratio of these two, dividing these two, you easily can get the radius of curvature. This is what is R? R is the radius of curvature. This is the radius of curvature. This is the fantastic formula for the radius of curvature. And now you have to find that what is the velocity. Since horizontal component, you know, this is the 6 root 3, and you have to find also the vertical component. What will be the vertical component? Since you know that Vy square equal to Uy square minus 2gh. What will be value? Let's solving here. Vy square equal to Uy square minus 2gh, because you have to find the final value, and you can determine the final value only when you know the component of the horizontal and vertical. Since horizontal component is fixed, this is the no problem here, this is always fixed, but this component is continuously decreases, and therefore you have to find this value. Since this is the Vx is always constant, and you have to find now the what is the Vy value. And just I am here, yes, I am solving here for Vy. Vy square will be how much? Uy was initial velocity along the y-axis was U sin theta. The putting value U sin theta whole square of the U sin theta minus 2gh. Putting all the values, U is 12, sin theta is how much? Sin 30. That is 30. Okay, sin 30. Sin 30 degree whole square of this minus 2 into 10 and into 0.4, because h is given 0.4 meter. Now solving, putting all values again. Since 12 into sin 30, 1 upon 2 sin 30, 1 upon 2 square of this minus this becomes, multiply this becomes 4 and minus 8. How much will be this? 2 into 6. 2 into 6, 6, this is the 6 and the square of 6, 36. 36 minus 8. 36 minus 8 means this is a 28. 28 meter. This is the 28. 28 meter means Vy square. Vy square equal to 28, and therefore the Vy equal to under root 28 meter. Okay, so this is the value of the Vy. Now since Vy is here, since now you know Vx equal to 6 root 3 meter per second, and Vy is how much? Vy is here. You got Vy equal to root 28 meter per second. And now since both the components are here now clear, both components x and y components, since you know that both components are perpendicular to each other, and by the law of the vector addition you can find the real value of the V. V will be how much? Under Vx square. Since you know the equation formula, you know Vx square, both two vectors, two velocities acting at the perpendicular means at the 90 degree, then what will be their answer? Vx square plus Vy square. How much will be that? V equal to Vx square. Vx square, Vx is so much, 6 root 3. 6 root 3 whole square of the 6 root 3 plus what is Vy? Vy is 28, root 28 whole square of the root 28, and solving this again, you will get V equal to under root 6, 36 into 3 plus root 28, 20 means that is the 28, and how much will be that? V equal to 3 into 6 means 18, 8, 1 and 0, 108 plus 28, and what will be the value? V equal to under root 28 and 8, 136. 136 means this will be the 28 and 8 means that is the 36, 136. So this is the 136. Okay, so 136, this is the value of the velocity, meter per second. So this is the velocity. Okay, check again. This is the velocity. Okay, this is the velocity. This is the Vy component, and that was the Vy component, and the Vy component, this is the Vx component, and therefore the final velocity is so much. This is the final velocity, V equal to so much. And radius of curvature, now again come on the topic. What is the radius of curvature? You know the radius of curvature. Suppose this is the final velocity V. Whatever be the velocity V. Radius of curvature, projectile always, any curve is given to you at any point, at any question, in any question. Suppose a curve is given to you. That curve always has some radius, and that radius is called the radius of curvature. Suppose here, what will be the radius of curvature? The part of this curve, a small part of this curve will make a circle. Then circle, suppose this part is making circle here, approximate circle is making here, this part of the curve. Then since you know the mass of the projected body, this is the m, this is the projected body, okay, this is the projectile. Since acceleration due to gravity acting g vertically down, center of this circle will be here. This is the center, means this is the your required radius. Since this is the g, let's draw a horizontal line. Let us consider a horizontal line, and this angle will be some change because this angle is the theta. Therefore, suppose this angle is the alpha. So since this angle is alpha, and you know the velocity is here v, so this velocity will be v cos alpha. Since this is the horizontal, this here horizontal component and here horizontal component, both will be constant, and therefore you has got the value, whatever be the value of the here means v cos alpha, that will be the always constant. But the question is, what is the component? What is the normal acceleration? Because you have to use here the normal acceleration. Suppose this angle is theta. Suppose this angle is the theta, means the angle between this velocity of projection and the horizontal line is the theta. Therefore, this what angle will be here? So this angle will be alpha. Since this angle is the alpha, and this angle is alpha, mind here, this angle is alpha, and this is the tangent, and this is the radius. Always tangent and radius both are perpendicular to each other. So therefore, this angle becomes now 90 minus alpha. No problem. It is clear. This is the alpha. Since always radius and tangent is always radius and tangent, means tangent drawn on any radius means any circle. Angle between the tangent and radius is always 90 degree, and since it is taken here alpha, therefore this angle will be 90 minus alpha. And since the horizontal line and the vertical line both are again perpendicular, so since this is again perpendicular, then ultimately this will be alpha. And let this is the alpha, and therefore what will happen, since this is the vertical acceleration g here, therefore what is here, you have to find the value of this. You have to find the acceleration at this. What is the acceleration at this? This is the g cos alpha. Okay, so this is the value of g cos alpha, and here will be how much? So this will be the g sin alpha. Therefore, what is your required answer? r equal the instantaneous velocity, square of the instantaneous velocity at this point upon g cos alpha. Okay, this is the concept of finding the radius of curvature. This is the very important for NET, also important for the IIT main exam, also important for the advanced. Okay, and now this is a very simple concept. This is the process to find the radius of curvature. Putting all the values now, since you know now that what is the velocity? Velocity is under root 136. So therefore, square of this, so square of this means 136 whole square of this upon g cos alpha. G cos alpha. What is the radius of curvature? 136 upon cos alpha upon g cos alpha. This is the g cos alpha. G, that is the 10 and cos alpha. Now the question, you have to find the value of the cos alpha. Okay, come on, very easily you can find. This value can be very easily you can find cos alpha, because v cos alpha equal to u cos theta. Since v now you have solved for the v. What is the value of the v? This is so much. The v root 136 into cos alpha equal to what is the u? U was 12 and cos was the angle of projection, and the angle of projection has taken 30 degree. So therefore cos 30. So cos 30. Okay. Cos 30. So you have to put the value of this cos alpha. So cos alpha, you have to put the value of this cos alpha. Okay. Cos alpha, you have to put the value of cos alpha here. So then now what is the cos alpha? Root 136 equal to how much? Put the value here. 12 into cos alpha. Cos alpha equal to 12 root 3 by 2. It becomes cancelled. Root 136 into cos alpha equal to how much? This is the 6 root 3. Now you can write this. Cos alpha equal to how much? Cos alpha will be how much? Root 136 upon 6 root 3. And therefore cos alpha you can write under root, this is also can be written 136 upon 36, taking inside the root 36, it becomes 36 into this is the 6 root 3. You can write this 36 into 3 inside the root, 36 into 3 in the root. Yes, you can write like this, and therefore it will be cancelled. Perhaps this will be cancelled. This is the value of the how much? This is the value of this value sum can be cancelled. Cancel some things. Suppose from 4 it can be cancelled. 160. Yes, 4 means this will be approximately, that will comes 4 means 3 and 4 34. You can write 4 into 3 12 and 4. Okay. And from 4 you will cancel this there, then 36 4 from 9 into 3. Okay, it can be like this, and it can be on more cancel. No, it will be so much. This will be the value of the cos alpha. This will be value of the cos alpha means 34 upon 27. Therefore cos alpha equal to under root 34 upon 27. Okay. So this is the value of the cos alpha. So since this is the value of cos alpha, 34 upon root 34 upon 27, and now put value here. Now put value here of the cos alpha. So since this is the 136 upon 10 into cos alpha. Cos alpha is root 34 upon 27, and it can be written as 136 root 27 upon 10 into root 34. Okay. this is the radius of curvature and it has to solve further. Therefore, now you can write 1 means that will be 13.6, it will be divided, therefore that will be 13.6 under root 27 upon 34. 27 upon 34. Okay, approximately it can be further solved, and this is the radius of curvature r equal to 13.6 under root 27 upon root 34. So this will be the value of the radius of curvature. Okay, fine. You can solve further. It can take the root. Okay, that will be the answer. This is the answer of this question. This is the answer of this question. So this was the small process. This was the process. This was not small. This was not small. This is the process to find how you can calculate the radius of curvature. Okay, thank you.